equals the square root of x squared minus 3 over 5. Oh my goodness!
Dr. Ward.
Well, what seems to be the problem here then? So, as we can see, the symptoms are y equals the square root of x squared minus 3 over 5. We have to get x on its own to find the cure. To do this, we multiply both sides by 5, getting the 5 off this side, putting it on this side, making it 5y. Over here, we have to get the square root away. So we square both sides, giving us 25y squared equals x squared minus 3. Now here we have 25y squared plus 3. Because we had minus 3 on this side, we plus both sides by 3, giving us x squared on this side. We square root all of this side, leaving us with x. We have now found the cure. You are cured, sir. Take 5 of this a day. You may go.
Thank you.
Well, looks like the day has been saved.
Hello, I'm Jaime Brugas and I'm an expert in volume. Today we're gonna look what's volume. Okay, for the start I have two figures. Here is a prism and the other one it's a pyramid. The first with the prism, what it has is a cross section, which is always gonna be the same thing. If you cut it in half, it always have the same cross section. But if you look at this pyramid, you will get the same shape but different sides. So it's not the same thing. After that, the other day I was playing around in the maths class and I was making this figure. I don't know how you call it, whatever you want. 3D shape, pyramid, house. And I was playing around and I was saying to myself, how could I work the volume of this shape? I mean, there's no way to do this shape, but I tried to do my best and I have 3 parts in this shape. The first one is this, it's a pentagon base with different triangles to the sides, but it's impossible. And here is a pyramid, a lovely pyramid in the top of it, but it's not I cannot work the volume of it. But here is the pentagon and here is a squared side, which that's what I did. So let's gonna make the pentagon. Cut it out, cut it. Well, here is my figure. Okay, as you can see, it's a pentagon base with a squares as lines. It's a 3D shape. And now we're going to find the volume. As you can see behind me, there is the pentagon. This pentagon. The pentagon, we divided in 5 different triangles. They don't look the same here, but they're supposed to be equal. As you can see, there are 2 angles, A, and B. And there is the height. What we're going to do now first is this. 36 degrees, which is the whole thing, divided by 5 triangles. 76, which gives us 72, divided by 2, because it's half, and gives us 32 degrees. So that's, it's going to be V, the angle V. So now we have to find the height. So that's where we're going to use our maths. Tan 36 gives us 3.5 by height, which is height 3.5 divided by tan 36. Height equals 4.8. Now you have 4.8 times 7, which is the length of each side. 4.8 times 7 divided by 2 gives 16.8. That 16.8 we times it by 5 because there are 5 squares, which we have found it's the area of one triangle, so we times it by 5, and that's where we get the whole area of the 5 different triangles. So it's 84, and that 84 we times it by 7, which is the whole length of the pentagon, and that gives us the whole answer. 488 centimeters cubed. And that's all for today. So see you next week in our maths program, and see you soon.
Now sold at 45 euros. That's right, 45 euros. That's 30% off the original price. I'm sure you're all wondering what our original price was. Well, to find that, x, our original price, minus 0.3x, 30%, equals 45, our fantastic new price. 1x minus 0.3x is 0.7x, which equals, again, our price. So finally, x equals 45 divided by 0.7, which gives us our original price of 64.30 euros. That's a whopping 19 euros and 30 cents. What a difference.
Hello and welcome to Maths TV. Me, Sam.
And me, Claire. On today's live show, we're going to be talking about
Factorization. Yes, Claire, we have Tony from London waiting on the line.
Hi guys, I was wondering if you could give me a simple maths equation to do at home.
Okay, Tony, here's an example. 12x plus 18y. You take the highest common factor, which goes into both 12 and 18, which is 6. So 6 goes outside the bracket. Inside the bracket, 2x plus 3y. This is because 6 goes into 12 2 times, and 6 goes into 18 3 times.
Thank you for calling, Tony.
Yeah.
Now we have our next caller on the line, Becky from New York.
Hi. I'm a little shy about this. I mean, I haven't done this before. Can you see me? Am I live?
You're live, Becky.
Good night, Becky. Yeah.
Okay, well, a guy in my chess club the other day said to me, you know what's really cool? You know what I really like in girls? The knowledge of factorization. So I decided to call up you guys and wonder if you could help me because I'm not too good at factorization.
Of course we can help you, Becky.
Yes, we can. Oh.
Okay, an example is 6r squared s take 3r s squared. To start off the equation, we have to break down the equation. So we break down 6 from prime numbers, which is 3 times 2 times r times r times s. We don't have to break.
You can't just see it.
We don't have to break down the second part of the equation because 3 is already a prime number. So we write it as it is: 3 times r times s times s. We circle the common numbers or letters in each side, which is 3, r, and s. This goes outside the bracket. And then inside the bracket, what's left over? 2r take s. Okay, Becky, thanks for calling.